In this video, we're going to calculate the discrete-time Fourier transform of the following signal. Now, the difference between this signal and the other signals is that it's the same as the type 3, which is antisymmetric about some value, but in this case, it just doesn't have a central element. We call these types of signals type 4 signals. So, as usual, I'm going to start by writing the equation for the discrete-time Fourier transform. Summation of n goes from minus infinity to positive infinity, x of n, and multiplied by e to the minus jw, or omega n. So what that gives you is 11 e to the minus jw4 plus 3 e to the minus jw5 minus 3 e to the minus jw6 minus 11 e to the minus jw7. So what we're going to do is that we're going to keep those exponentials that have the same factor together, and we are going to factor a central element that will be e to the minus jw 5.5 because it's what would be between the two of them. It's between e to the minus jw5 and e to the minus jw6. So let's keep these guys together and happy. What that's going to give you is, let's say, 11 e to the minus jw 5.5 times e to the minus, or rather plus jw 1.5 minus e to the minus jw 1.5. Yeah, that's right. Plus 3 e to the minus jw 5.5 times, we're going to move this guy right here, e to the jw 0.5 minus e to the minus jw 0.5. Okay. So what is that in terms of trigonometric functions? Well, that's really just 11 e to the minus jw 5.5 times, since it's a minus sign in the middle, then you get 2j sine of, let's make this neat, 3 omega over 2 plus 3 e to the minus jw 5.5 multiplied by, again, it's a minus, so 2j sine omega over 2. Okay. So let's go back here. Let's take out the j and remove the factors 11 and 3. So we would have e to the minus, or j e to the minus jw 5.5 times 22 sine 3 omega over 2 plus 6 sine omega over 2. And that would be in exponential form. So this guy is your p omega. Okay. So what about the norm, or the modulus of the Fourier transform? Well, the modulus of j is equal to 1 times the modulus of the exponential term, which is also equal to 1 times the modulus of p omega. So really what it is just p omega evaluated at some value of omega. Okay, what about the phase? So the phase would be the phase of j, which is 90 degrees, pi over 2, plus or minus the phase of the exponential term, which is everything in front. That's multiplying the j term. So that would be minus 5.5 omega plus k pi for the polynomial. So let's circle that answer, highlight that answer. It's all of this. Again, there's a PDF worksheet in the description. Thanks for watching.